Hi there, I am Teemu Lehtinen and my co-authors are Andres Santos and Juha Sorva. Today, we describe an issue in teaching programming and discuss a possible method to address it. Here, we see an example of an automatic assessment system from a teacher's perspective. While students work on their programming assignments, these systems enable teachers to monitor correctness and perhaps other qualities such as style or efficiency of the programs that students submit. While points are gathered and more test cases pass, teachers may get fooled and think that all students who created a correct program also understand why and how it works. In the small string transformation function, student is redundantly making a string conversion using a structure that is not introduced in the course material at all. I wonder why this unnecessary and alien code appeared, and as it is superfluous, did the student understand the code? We have seen that many students apply little understood code fragments from various sources, such as textbooks, student peers, or internet searches. Trial and error combined with Q&A support or automatic feedback can help to form a functionally correct program without reaching understanding. Evidence of issues in understanding one's own program are found in Salak and Franklin 2020, Kennedy and Kramer 2019. What we describe is a dual issue where, from one perspective, students should reflect on their code to ensure their understanding. And at the same time, the assessment is limited to the submitted program, ignoring comprehension of that program. A natural way how teacher might address this issue is to start a dialogue about the created program with the student. Teacher can ask student to explain details of their program design and execution to assess their understanding. However, increasing course sizes and distance learning have limited such one-to-one teaching opportunities. We propose that useful questions about student-written programs can be created automatically and posed to the student by automated systems. Here is an example to illustrate our idea. Let's assume this Java program was created by a student. The assignment was to write a recursive function that finds the smallest character in a string. The program is recursively called for each character, which is compared to the smallest from the rest or the last character. Once student has completed this code, the system could automatically generate questions including: you wrote 2 functions. Which of those are recursive? What are the parameter names of your function smallest from? How deep does the call stack grow when executing smallest uppa? When executing smallest from ACDC 0, which character is assigned to rest during the second invocation of smallest from? Or which of the following best describes the role of your variable rest? A temporary storage for value used later, B, a gatherer that repeatedly combines a new value to itself, C, a most wanted holder that is repeatedly replaced by a more appropriate value. We define these questions about learner's code, or QLCs, as follows. 1. They are questions about program code that student has written. 2. They refer to concrete constructs or patterns in the student's program. 3. They are posed to the student themselves by a computer. And 4. They are automatically generated from an analysis of the student's code. This paper discusses foundations of the QLC's idea in detail. We argue that QLCs can help with learning program comprehension and strengthen the relationship with program writing skills. QLCs could be also designed to work as self-explanation prompts. Self-explanation has a known positive effect on learning. The paper proposes a general process for generating QLCs. A student's program is statically analyzed for facts such as what variables and constructs the program has. Additionally, the program is executed so that dynamic facts such as variable values and call stack history can be collected, beside existing analysis methods that can produce those static and dynamic facts. We propose that QLCs are designed as templates that can be first filtered to applicable ones and then instantiated to actual questions using the previously collected facts specific for the student's program. Different QLC templates that target different levels of program comprehension are demonstrated. The paper discusses use cases of QLCs in programming education and presents a particular use case, how we initially plan to employ QLCs in automatic assessment context. Challenges and limitations that are necessary to note in future work are described. Since the paper, we have constructed a technical proof of concept that follows the described generation process. This implementation takes a Java program as an input and generates QLCs similar to the different types we included in the examples. We have also experimented the idea by presenting manually prepared QLCs targeting selected programming assignments. Qualitative and statistical analysis of that study are reported in our next publication. In our future work, we continue to research generation, application, and effects of QLC activities in programming education. Thank you for listening.
All right, interesting paper. So any questions for Teemu? Please put the question in the chat. Okay, the first question from Alexander. How did you identify?
Thank you for asking. We use this block model. That's a model for program comprehension used in the computer science education, and we tried to make example questions, templates of such questions that can target different levels of understanding, like from surface level of, let's say, terminology or something, then to the execution of single lines or bigger blocks of program, and finally to something like a purpose of a variable or something in the code. And then we thought that it is possible to target these different levels of understanding.
Okay, thanks. Okay, any other questions from the attendees? Okay, maybe I can ask one question for now. So according to the question templates, do you think at some point the student might also recognize the template and they can also prepare the answer in advance?
Yeah, I think this is one of the challenges that we also list, that we have to somehow perhaps know the current knowledge of the student, because it can be also very annoying if the same type of questions repeat and you can create the program, but you have to explain again and again. So this is probably one of the challenges that we are going to face when going forward.
Okay. Okay. So I think your work still in the process of doing this evaluation, right? So can you have some something to share? What did you find?
Yeah, we have a upcoming paper we cited. It's going to be in ITITSE, and here there we test some manually pre-prepared questions that seem like the QLCs that we are talking about here. Mm-hmm. And it seems that the issue is real. This adds to the evidence that some students don't understand their own programs very well, and also that better understanding does correlate with course success and retention. So it sort of makes future work worthwhile.
I see. All right. And I think we at the end of the QA. So thank you.